Yeah, now tell me, what did you learn about hashing? What things are unclear to you?
We learned about like open addressing and chaining. I'm still confused about the difference between open addressing and closed addressing.
Cool. But you see, there are three topics in the hashing I would like to cover from the interviewer perspective. Say, if I ask any candidate an interview question, I'll look three areas. One, are you clear why hashing is? Two, uh, are you able to know how the internal implementation of hashing? That is where collision resolution techniques are there. And number three, are you good to apply hashing in your projects if I hire you? Third one is most important. But to learn application, you should know how internals of computer science have been, any programming language have been implemented using the hashing techniques, because the hashing is everywhere and you can't get away from hashing. No matter what role you will be getting, like STE or data engineer or data scientist, anything related to coding or queries, SQL queries, or any technical job in the computer science involves hashing. And it's not rocket science. It's a simple array. But let me start sharing my screen and represent you diagrammatically what is in my mind. This is what is some good blog explaining through a diagram. Actually, I would like to represent one more diagram, but yeah, I will go back and then come here. Before chapter 5, I have added one more diagram. Is it? Yeah, this one. So you know data structures. I'll come back to that in the second half. But this in this first video, let me cover you the fundamentals from the interviewer perspective, which you should not miss. Tell me, these are all primitive, which any language has almost
Mhm.
same kind of stuff. You know this very well. In your
Yeah.
semester one, you have learned about programming fundamentals. In the semester two, you are learning about arrays. Dive deep. Even in Sem 1 also, you should have learned in C programming. Stack, queue, linked list. These are linear data structures. Non-linear are trees, and heap is a special type of concept, which is kind of both. And then try we'll cover later. Graphs, next chapter. Hash table is what we are covering from now. The question to you is, what is the core requirement for this many data structures in computer science? Why we need to learn all these data structures? I'll come another way. We have arrays. Then why do we need stack and queue? You can do everything through array, right?
Because sometimes it's like more time efficient to use stacks or queues.
Technically, stack and queue can be implemented using array. So array is kind of generic, but you should know the basic operations of array. But using those, you will build stacks and queues. If I want to give you clarity, array is like a hall or a living room. You have just four walls. But stack and queue is like kitchen or cupboard kind of stuff. You will still use array, a living room, to build these data structures. Okay. Now, why do we have linked list? It is kind of office room, which can be, or maybe a sports room. So everything needs a land and walls, but the purpose is different and you will have a mix of things. So, but overall, the goal of anything is, you suppose Why do you need a cupboard? So that the most valuable things, or maybe your office clothes or anything, or books, you need to store in a specific place so that you will easily grab those without spending more time. Same way in computer science, searching is the costliest operation. If you and most frequent operation. Example, if you go to Amazon or Google, these companies are living by what? Fastest search feature. They have been successful for over 2 decades because of their best search results. Why? They use the innovative algorithms and the internal arrangement to search in Amazon products, whatever you want. Similarly, they pre-process the products based on your name, age, and gender. So that way, to do all such create innovative algorithms, you need more advanced data structures like trees, heap, based on the requirement. You need those. And you cannot get a quickest search better than hashing. Hashing, if I want to give you overview, hashing you can treat like, hey, if you go to a movie in a theater, fourth row, fifth seat, each row is having 10 seats, say like, or maybe 100 seats. Fourth row's 10th seat, you are assigned. So how do you search? Or how can I give you that code? I will give row number D, seat number 10. So D10 is your code. That is what hashing is all about. It's a pre-processed arrangement of data so that you can easily find its address from that particular location and access the data inside that address. Here, addresses are represented in a big memory, or I would say, like in movie theater, they are like a pre-processed arrangement of two-dimensional array. Sometimes you might need one-dimensional, sometimes two or n-dimensional, but it doesn't matter. Hashing concept is same. What is that? A pre-processed arrangement so that it is easy to access or modify the data compared to just a simple array. Because array searching is how much time complexity it takes. We go off. Quick sort takes how much? Quick or merge sort and log n. But hashing takes big O of 1. Reason? Cinema hall, you don't need to search each and every seat. You'll just go to that row, fourth row, 10th seat. That's the power of hashing. And that is most important to learn further courses like databases or anything related to encryption, decryption, or searching or large scale systems files. You need to learn hashing. Now let's come back to the concepts of hashing. You need to know like what is the way to come, how internal implementation of C++ or any programming use hashing. And then that is basic thing. You don't need too much details. Usually you use division or multiplication techniques popularly. And then always there will be a collision happening, right? Sometimes 4th through 10th, but it can be from left side or right side. It can be a collision. Suppose if it comes in the memory, you need to find other place to arrange that seating, or maybe two users simultaneously created that and something happened and collision happens. So in such situation, you need to find a way to reassign that address. That is what collision handling. And you, as you said, you have two techniques, chaining and open addressing. Chaining means using a linked list separately, one after the other. Whereas open addressing means you have again separate formulas to do that. Linear probing means you need to use linear algebra, maybe a power one equation like ax plus b plus c, or maybe b kind of equation you need to use to arrange elements like 2 into that address or 3 into that address, something like that. Quadratic means ax square plus bx plus c kind of equation to find some other unit. I address if there is a collision happens between two data elements. Double hashing means find another formula on top of this formula. Okay, so I have used some formula to get hashing. Say like I used some division method or multiplication method. This is not working out because it is still created a collision. In that address, create again a hashing. Add one more hash function so that you will find another address. So just keep that in mind and we will see some examples. But this is very good diagram. You can go through that from page 106 onwards. Let's go and see a simple hash technique. This is most frequent interview question. They'll start you to do a division or multiplication hashing in the interview, and time is only 10 minutes to you. You can start with it and then improve it further. Simple one is you have an array of 1,000 elements. For now, 1,000 means 997 is some prime number. But ideally, you can still divide with 1,000, but there will be more multiples. But if you divide anything with a prime number, the advantage is you will get more uniqueness compared to dividing with a non-prime number. That's why I took 997 for an example as a prime number in 1,000 memory. And, uh, key is some number which you want to store and divide it with that prime number. That is the simplest hash function for numbers. This is the simplest. You can also use random number generation in math. That is a rand function. It will give you a random number and multiply that with the table size, which is 997. But I would say random numbers sometimes will be this is also another way. You can use anything. But what is important is just remember prime number division is better to create uniqueness. Random function will give you a number between 0 and 1. So that's why I should multiply it with 1,000 or maybe key into 1,000. That's the reason why I did this. This is more common if you see a DITL book, DITL C programming or any book, you will find this kind of random function too many places. But you can directly do this way as well. Take a prime and do. Interviewer doesn't mind as long as you are creating a unique address. Now, if it is a string, how do you handle it? See, key means if you go to the main function, I'm sending a number. This is the value I need to store. So I simply divided it with 997 and I will get some address. Okay, that is simple. That address is this one. Some hash code I got. I think this is wrong. I should get something below 1,000. I was testing something else. Let me try Visual Studio. I'll get some other address too. For now, just keep that in mind. It might be 991. Or I can do it through calculator. 1, 2, 3, 4, 5 divided by 997. So it is 12. I got 12 for the integer. So I keep trying with negative test cases, so I got that result if something is wrong. But so most important is you will get something between 0 to 997. That's the modulus operator's property. It gives you the remainder of the division. Now, if it is a string, you need to convert that string into integer. That's the reason where you need to convert that to integer using this concept. But see, remember, internally strings are stored using ASCII codes in C, C++. So the ASCII code multiplied with something and then divide by the table size. Technically, you can directly divide that with table size. You can simply remove this as well. You don't need to really care that too. But just something little bit advanced I gave here. But this is something you need to write in the interview. But what is the important thing?
What does 31 mean?
It's some prime number. That's it.
Okay.
You can give anything. But most important is modulus division. That's the important thing in the division method. But use always remember prime members give you uniqueness. That's the concept. But remember, any kind of technique you use, there will be a collision happening. How can you handle? That's something we will discuss in another video. But right now, I would like to show you one more way, that is multiplication technique. One was the division technique. You need to divide it always. Multiplication is almost same. Multiply with a prime number and then divide by table size. This is what I did for strings in both the cases. And similarly, see, what's important is you don't need to divide, but you need to do something else to get some big value. So this is golden ratio in mathematics. So multiply anything with golden ratio to get some unique value. That is what multiplication technique tells you. Golden ratio in mathematics means square root 5 minus 1 divided by 2. That is 1.6 something. That is present in mathematics. If you don't remember golden ratio, as I said, simply multiply with any prime number and
Okay.
divide by another prime table size. That's it. So, but always still at the very end, you must divide by the table size
Table
like
size.
this. But in this, since we are already multiplying with fraction, it's internally already using the division technique. So for the initial one, so I just gave you various flavors to play with, but in the interview, in that tension, you may not remember all. Just keep prime number concept in mind. Whether multiplication or division, use prime number to multiply or divide, or to do both. They don't care you
And that
whether you
number
use
can be any number?
within, yeah,
Any
any
prime
number
number?
within that table size.
Oh, yeah.
You should ask interviewer what is the size of a hash table. And in that table size, it's like movie theater. I need to give a random seat for you. How many seats are there? If I have 200 in that theater, I must divide by 200. Or a prime number, multiply with a prime number and divide by 200. Prime number of any prime number is also okay. That gives you a unique value. Or the other way is multiply with a golden ratio and then multiply with a big value, big rounded value, and then divide with a table size. So you have a lot of options. The goal is to create unique thing. To create any unique thing, prime number is better choice. Or a golden ratio. That is a reverse prime number. It's a square root 5 minus 1 by 2 is the most unique fraction in the golden ratio. Sorry, in the mathematics. Cool. So now this is first step. Interviewer doesn't satisfy with it. You can go through the explanation given here, but interviewer doesn't satisfy with that. He wants to know how would you handle collisions. For that, once you have created these functions, you should compare whether that address is already having a value or not. If that address is already having the same, say like if the same person is already, somebody is already booked online and in that physical location also they assigned you row number D, seat number 10. So now I need to handle this collision using one of the popular technique is separate chaining. This is a hash table. Add a linked list to this and then create a linked list, store that address as well, that head of the linked list. So anytime if more people are there, I'm adding an extra chair at that location by adjusting the seats. That is what this concept is. If anyone gets D10, create a separate road for them and then move them, redirect them to here. You see frequently in airport as well. So whenever I get a similar ticket to two people, the air hostess will, sir, please go to business class. There
Yeah.
are vacancies. This is like that. That is called a separate chaining. This is a separate linked list and stores that value and then put it here. Linked list address is here. So that John Smith and Sandra D both are having address 152 collide, but linked list is having an extended memory in that hash table. What is the drawback with it? If you have more number of collisions, this will become a linked list search.
Time of, yeah.
If I want to search for Sandra, Sandra is not available at the first search. What is the purpose of hashing? I should get it in first lookup, but it needs second lookup. And it goes on like a long linked list in a million element table. If you receive a million collides, it becomes a linked list, not a real hash table. So you need to find more best prime number combination or multiple innovative ways to get uniqueness, unique addresses. That's why we keep, the reason why I would say is in Amazon supply chain, we need to find similar algorithm to find a unique address in the where? Fulfillment center. I have a lot of boxes and I have a lot of locations. I need to find a unique address to place location in Amazon fulfillment center. So a lot of collisions happen. We need to test a lot and then put right place to utilize 100% of the fulfillment center. Means the other locations rather than keep on extending a linked list. So that's the thing interviewer would expect you in the second thought. I have written implementation to that. It is already known to you. Create a linked list of integers and then add it to your hash map. And your function should take care of checking whether collision is there. If the collision is there, add it to a linked list. It is like mixing two programs, our previous program and your linked list program.
Mm.
And I have given explanation here with the output. You can play with it. Remember to use these commands because these are done on my Mac computer. Okay.
Okay.
Now, open addressing. I would like to take a few seconds break and then create a new video to continue this. I don't want a lengthy video.